Hi, my name is Joe Pior with Blue Marble Consulting, and today I'd like to show you the SAP Predictive Analytics on HANA tool. What we can do using this solution is analyze in real time large volumes of data and use that to predict future trends as well as evaluate the impact of various corrective measures on these trends. So in this instance, what we've done is linked this tool directly to the HANA database, although there are many ways to import data to analyze into this tool. What we can see right now, we have our actual maintenance cost by equipment by year. So what we're going to do here is we're going to take a look at which equipment costs us the most to maintain. We're also going to look at the reason for this, and next we're going to take a look at the impact of improving our maintenance strategies for this equipment, and then finally we're going to determine the appropriate maintenance interval to reduce breakdown for this equipment. So right off the bat here we can see that pumps cost the most to maintain of all of our equipment here in this view. So we'll go ahead and filter by pump. And now that we have this filtered just for values for the pump equipment, we can go to the Predict tab and basically just let this trend run. See what would happen if we took no action and allowed this to continue with the current maintenance approach in place. So we can see here, we get our table values first. We'll go ahead and look at a chart view. And so if we were to continue with our current maintenance plan, we would see, as you can tell here from our blue actual values and our green predicted data points, that our maintenance costs would keep rising. So let's go ahead and do a root cause analysis to see why it costs more for us to maintain the pump than other equipment. So we'll once again filter here by pump. And we can now go to the Visualize tab, and let's take a look at a bubble chart view this time. So we're going to take a look at time to repair as well as time between repairs. We'll also take a look at actual maintenance cost, and we'll take a look at damage code as well. So here we're seeing time to repair based on different damage codes. We can also take a look at the actual values here in costs. We're not seeing any apparent trends to provide us insight into our problems. Let's go ahead and go to a heat map view. And here we can see that overheated is important to look at as a damage code because it results in a high time to repair, meaning that our equipment is out of service for longer. But let's also take a look at cause code as well. So we can see that this overheating up here is often caused by poor preventative maintenance. So let's say we were able to change our maintenance approaches and correct this cause, which results in the elimination of this damage type and some other ones that we see here as important indicators. So let's simulate that by going to our damage codes here in the Prepare tab. And let's say we were able to change our maintenance approach and actually eliminate broken, broken/torn, overheated, and unbalanced damage codes. So we'll exclude these values, and we'll run the same predictive model again. And once again, we're going to switch from our table view to our trend chart to get a visual representation of this data. And we can see here that based on our data points here, our predicted data points, our costs would decrease if we were able to actually reduce those damage codes with our better maintenance plans. So the next step is to go back to our designer view here and take a look at the appropriate maintenance interval to avoid equipment breakdown. So we're going to click on Add Analysis, and we'll go into our algorithms and select the appropriate decision tree algorithm. and we'll go ahead and configure that for the values we're looking for. So in this case, we want to see a trend, and we want to see time between repairs and damage code as our target variable. So now we'll go ahead and run this model here and take a look at our results. So we can see here that if we choose to maintain our pumps at maintenance intervals of less than 481 hours, we can prevent them from breaking down. So what we've seen using this predictive analysis tool is, first of all, which equipment costs us the most to maintain. Second of all, the root cause of that increased maintenance cost. And then we can go on further to see the actual optimal maintenance interval to prevent equipment breakdown. So as you can see, this is a very powerful solution, not just for this particular scenario, but in general, in a variety of industries and scenarios. Additionally, we can take a look at hypothetical scenarios, such as if we were to improve our maintenance plans to eliminate certain damaged codes and see the result on our data as well. If you would like to learn more about the solution, please contact Sabrina Sigourney of Blue Marble Consulting or visit our website at simple